So I had this idea. Why don't I create my own video game using this 4-panel LED, an Arduino Nano, and some buttons. I was thinking of creating a side-scrolling shooter where a spaceship shoots enemies that come at it from this side of the panel. So I have all the pieces here to make this game. But if somebody wants to follow along with me, they need to find all of these parts, and there's going to be soldering required and all that sort of stuff. And I began to wonder whether I couldn't do it somewhere that was better, or some way that was better for the end user, for the person watching the video. And since AI has become a thing, I also wondered whether or not I could use AI to help me write the game. And in that way, anybody that was watching the video would also be able to take what I'd done and use AI themselves to answer any questions that they might have or things that I didn't cover in the video. I feel like AI is the way of the future for people wanting to learn things and for people wanting to teach things as well. So that's what I'm going to do in this video. Instead of physically creating this game, which I still might do, I'm going to create this game using an online emulator that anyone can access from their web browser. And I'm going to show you how to use AI to help you with the coding. It's going to be great. This is the website I was talking about, the online Arduino or microprocessor simulation website. It's called Wokwe. Well, that's how I'm pronouncing it anyway. There's a number of these emulator sites on the internet. I just chose this one. I used it. I liked it. I'm not an expert at all. But here we go. So I'm going to go down to a section here, start from scratch. And here you can choose the microprocessor that you're going to use. There's the ESP32, but we're going to use the Arduino Nano today. So I'll click on that. You can see on the left-hand side of the screen is the code that would normally be entered into the Arduino IDE application. And on the right-hand side is basically a circuit simulation of all of the components that we're going to be connecting up. So to begin with, we need to add the display that I showed you earlier on. So that's this LED dot matrix, max 7219. Two, I only want one. And we're going to have some buttons, which we're going to use as the controller. So I'll add a push button. And then I think I can press D and it will create a duplicate. Yes. So we want 5 buttons. We want one as the fire button. We want one as the down, the up, the back, and the forward. Okay, that will do. To begin with, the next step will be to wire it up. To figure out how to wire up this LED matrix screen, we can press on this question mark and it will take us to the reference for this component, which will explain how it works. And also you can go to some ready-made examples of how it's going to work. But what I wanted to do was to show you how you can use artificial intelligence, in this case ChatGPT, to help you out. So what I'll do is I'm going to ask ChatGPT to help me out with some code. Now you have to understand that even though ChatGPT seems like it could write you a complete program, it really can't. It's very good at writing you parts of programs, of giving you examples, of answering your questions about coding and things like that. But it is very limited to how much it can actually do. It's sort of like having a colleague who is a little bit absent-minded or doesn't have enough time, and you go and ask them a question and they say, oh yeah, sure, you just do this. And so you go off and you do that, but then you don't quite understand what's going on, so you come back and ask, and that may or may not be helpful. Anyway, so we're going to ask it, well, first of all, so we're going to tell it what we're doing so that it has some context. So I am programming an Arduino Nano. Okay, so I'm giving it actually the processor that I'm using because it will understand that the questions that I'm asking are relating to an Arduino Nano and not just some random Arduino board. So it's giving me a whole bunch of information about it. So then I can give it some more information. I am using a Max 7219 LED module. Can you write me some code to test that it is connected? Okay. So it's probably going to do a good job of this because it's a very small amount of information or code that I'm asking it to write. If you ask it to write you too much, it will get confused, or it will pause, and then it will forget what it's already told you, and it will give something a little bit random. But you can see that it's actually produced a nice little Arduino sketch that we can use, because the first thing we need to do is we need to hook it up and we need to test whether or not it works. There's no point writing any code if we can't make the display work. So I'm going to copy this code and I'm going to go back to this section and I'm going to paste it into here. Now, the first thing you can see is it has defined these pins. So the digital 11, pin 10, pin 13 as needing to be connected. And these are the pins over here. So we've got a voltage, we've got a ground, then we've got DIN. So that needs to go to 11 according to it. And the CS pin goes to pin 10. And the CLK, or the clock, needs to go to pin 13. So we need to wire it up that way. So the first thing I'm going to do is I'm going to find let's see if I can zoom in. Yeah. So I'm going to find, so the first one here is the voltage, and there's a 5-volt pin here. So I just click on that and then I shall bring it up here and bring it to the voltage. The next one is the ground. So I'm going to do something similar. Click there, and to the ground. So now next is the DIN pin, and it says that we need pin 11. So where's pin 11? There's pin 11 there. So I will bring that up. Bring it up here. The next one is the CS pin, and according to that it's pin 10. So we'll come down here, connect that up to pin 10, and finally the clock, which it defined as pin 13. And that's all the way around there. So we'll come down So there we go. Now, I have no idea whether or not that's correct or not for an Arduino Nano, and it might not be correct, but this is a start, and this is where I would normally go and look up the pinouts for an Arduino Nano, and I'd probably Google some questions on, what's the correct pins to connect one of these modules. But it's costing us no effort to just follow this. And this is a really important lesson with ChatGPT, is you don't really know whether it's 100%. You might have to refine it. And that was a hell of a lot easier than actually having a physical board and soldering wires and things like that on it. So I'm really excited to see whether this works. So there's our code produced by ChatGPT. We've wired everything up. We haven't touched the buttons yet. We're only interested in seeing if we can get the display going. And if we look at the code, we can see that what it's going to do is it's going to initialize the lead controller, and then it's going to do a loop where it turns on some of the LEDs, and then it's going to pause for a second, and it's going to turn the LEDs off. All right. So let's press Start Simulation and see what happens. Okay, and then we immediately get an error. So LED control.h, no such file or directory, include LED control.h. Now I know what that's complaining about. So it's defined a library that contains the routines that required to use this module. And in this particular, the WOCWI thing, you have a library manager. And you can just add the libraries here. So if we just type in LED control, hopefully that is the right library that it needs. We go back here, start the simulation again, and there we go. And you can see that that's correct. It is actually lighting up one line of the LEDs over here. So that's great. So we have a test sketch here provided by the AI. We've connected up as requested, and we're off and running. That's great. It's such an easy thing to do. Next, we need to figure out how to wire the buttons up. So I'll go back to a ChatGPT, and we will enter in another message. I've already cleared the previous one. It is a good practice to continue on the conversation, but you also have to be careful about continually adding extra functionality to the existing code, because it will eventually run into, and quite quickly run into, a problem where it won't be able to produce enough code. It will forget what it's doing, and it will start producing some very random stuff. So if you can, it's better to ask it a very specific question. And in this case, I'm coming back after some hours. So I'll just start again. So I'll say, I'm using an Arduino Nano, and I have 5 buttons connected. Can you write some code to test that they are working? So it looks as though it's defining the 5 button pins that we need, and it's also setting up some serial debugging, which will be how it will tell us whether or not the buttons are being pressed. As the buttons are pressed, it'll write something to the serial port, and we'll be able to read it. And yeah, that's exactly what it's saying. It defines 5 constants for the pins. Okay, so that's great. So we could copy and paste this over the other code, but I think maybe because we've already got some working code with the display, I'm going to add this to that. So what I'll do is I'll copy these constants and I'll place them over here with the other constants that we have in the original program. And we can see that this is the code that needs to be in the setup section. So we will go to the setup section and we will just add the extra code. And then we can go to the loop section and we can use this code. And we will put it down here. So really we're just adding to the program. I can't stress that enough that, you know, the ChatGPT is not capable of writing entire programs. We've probably almost reached, with those questions, have reached the limit of what it can actually give us. But really, so we're building up our program here. So we've connected up the display. We know that that works. And now we have 5 buttons and we've defined 5 pins. And as those buttons are being pressed, they are going to write something to the serial debugger or the serial output, which I'll show you in a second. But obviously we haven't connected the buttons up. So the reason that I did this first before I connect the buttons up is I need to know the pins that it thinks we need to use. And it's saying use pins 2, 3, 4, 5, and 6. Okay, so that's 2, 3, 4, 5, and 6. So the way that we need to connect these buttons up is that we need to connect them to those pins, but immediately I see that this isn't going to work. But that's okay. Well, this would be an interesting thing that we can do for chat to see whether or not how smart ChatGPT is. So with buttons, what you need to do is you need to connect one side to ground and the other side to the pin that you want to use. And with these buttons, I'm pretty sure that you need to connect. There are 4 pins, and the pins are 2 of the pins are connected together. And so what you need, so these 2 pins are actually connected together and these 2 pins are connected together, and you need to connect ground to one side and this side to the input on the board. The reason it has 4 pins is actually usually because when you solder them onto a board, you need 4 pins to anchor them. So we need to connect ground to one side of each of these things. So I'll go ahead and do that. And hopefully I can just click on there. Yes. And connect to that. And then, like I said, this will be connected through that. So we will connect that to there. Then we can connect that. How we do this? To there. And we can connect that. It looks a bit dodgy, but it's the easiest way to do it. We can connect that to there. So basically, that side is connected. Each one of those is connected through to ground. Actually, we can change the color of this wire, I believe. So to black. So just by clicking on it and then going up to the top and selecting the color, we can change the color of the wires to make it more obvious what they're doing. So basically each of those buttons is now connected to ground. And now we need to connect each of those buttons to the pins, which are defined over here as 2, 3, 4, 5, and 6. So we will take the pin here. This is going to get quite it's going to get quite crowded coming all the way over to here. That's okay. So where did we want? We'll connect the first one to there. And then we want to connect three. You can see how if you did this in the real world, how quickly you would have a rat's nest of wires. So he's going to 4. That 5 there, yes. Going to 5, and the last one needs to go to 6. I'm assuming that is 6. They're not always logically next to each other, but in this case they are. So yes, I know that looks like a bit of a rat's nest of cabling, but what I'm doing is I'm connecting one side to ground and then the other side to a pin that's already been defined. So if we run that, let's see what happens. Okay, so you can see that it's outputting the state of all of the buttons. So button 1 is 0, button 2 is 0. So if we press one of these buttons, it's not doing anything. I know, button 3 did turn to 1. I need to, oh yeah, so I can scroll in and out. Okay, so let's press this button here and see what happens. So I'm holding it down. Now what I'm concerned about is that, I'll just stop this for a second. What I'm concerned about here is where it sets the inputs over here. And really you need pull up or pull down resistors in order for this to work. But you can do the internal pull up and pull down resistors inside the Arduino, but you have to put some special code in here. So what I can do is I can copy this code and I can go back and I can ask what is the correct way to code this. I think, as I should say, I don't have external resistors. Can you enable the internal ones? Yeah, and so it's saying, yeah, I understand what you're saying now. And you can see now it's changed its code, and instead of input, it's got input pull up. And it's rewriting the code for us. So we'll let it do that. We'll see what happens. We should be able to just, yeah. So if you had pressed the buttons and nothing had happened, then obviously you come back and you would say, hey, it's not doing this, and you would actually get something sensible out of it. So I'm just going to take that and we're going to just replace that because that's all it actually did change. And also we have a big delay in here because it's refreshing the LED here, and that might cause the debug output to not look right. Okay, so here we go. So let's press a button. So that must be button 4. You can see it's gone to 0. So it was 1, now it's gone to 0. So let's press another button. So now button 3 is gone to 0. That means it's being pressed. Button 5. Yep, so all the buttons are working now. So you press the button, it goes from reading a 1 to reading a 0. Excellent. So we have a working display and we have working buttons. So now we can move on to the next section, which is how do we make a spaceship? This is what I'm thinking, is make a spaceship be drawn onto the display and move when we press a button. I want to ask Chat to help me out with figuring out how to draw the graphic of the spaceship on the screen. Now, what I want to do is I want to limit the amount of code that I give it. This is pretty much its limit here, this application here, I would imagine. And what I found is the best way is to actually come up with examples, very specific examples about what you want, and give it to it. And it will be able to use those examples to give you what you want. Now, this WalkWe website only lets you work on one project at a time. And you have to save it. Maybe the paid version lets you do it. I'm not 100% sure. But what I'm going to do is I want to save this code because this is the code that we're going to end up adding to all the time. I'm just going to bring in Notepad++, which is a text editor. I'm just going to copy the code into there. So I'm going to keep that safe. And what I think I'll do is I will remove all of this pin stuff from here. And just, I want Chat to see the code that it's using, that it's already been created to display. I don't want the buttons to get involved in the process. And so we're trimming it down to a nice, neat little example. And I can just run that to check that it still updates the screen. Yep. So now all the button code is gone from that example. And that's something I can use with Chat. And I will say to it, given the following code, can you show me how to define a sprite of a spaceship in a 4x4 size, because I want it to be, say, 4 pixels by 4 pixels, given that we have 8 rows. Define a spaceship and display it on the screen. And then I'll just copy and paste the code. Hit enter and we'll see what it comes up with. Okay. So to create a spaceship in a 4x4 size, we need to create a 2D array of Boolean values where it corresponds to the lead in an 8x8 matrix. Yeah, that doesn't seem correct. Two variables to center the spaceship. We iterate over the 4x4 spaceship array and use the setLed method. Well, the only problem there is it's not a 4x4 array. It's actually 8x8. So let's see if we can get that to correct that. You have defined an 8x8 array. It needs to be 4x4. So that looks a little bit better. So let's put a couple of variables, start X and start Y, top left corner of the spaceship. Okay. All right, so I'm not going to ask it to do any more coding with that. We're just going to see if we can't reuse that. So we'll go back to our example here and let's copy in that spaceship array. And we'll copy the code for the loop. And we'll replace that. Okay, now I immediately see that this is using a start X and a start Y variables that aren't defined. But let's just see what happens if we compile that. Oh, where did the start X and start Y come from? Oh, they're right here, so they're not global. I was expecting them to be global because they would need to be global in the real program. But in this example, that's perfectly fine. So we've got a graphic displayed on the screen. So if we go and modify what this graphic looks like, I'm going to try and make a little spaceship out of this. Maybe something a little bit triangular. So where there's a 1, it'll light up a pixel, and where there's a 0, it should not. Let's have a look at that. Okay, that's great, but it's backwards. So the way that it's displayed on the screen, it's going in this direction. It's not going in that direction. Go back to chat and ask it what's going on. The sprite is facing left when it should be facing right. That's a bit cryptic. I really don't expect it to understand what I'm talking about. To flip it, okay. We can simply reverse order of the columns. Well, yes, that is a solution. But I'd like to change it in the code. Can you modify the code to flip it instead? We've modified the while loop to start at the last column and count down to the first column. Okay. So let's just see how that works. Here's my little spaceship. Nice. Okay, so next we want to make this a bit more usable by having methods which draw the spaceship and erase the spaceship. So let's try that. Can you create methods or functions? I think they're called in C. Called draw. Actually, let it decide what to call them. To create functions to draw and erase the spaceship. The functions should take an X and y parameter. You want to try and give it as much information as possible. So here it is. So draw spaceship takes X and Y, and it looks to be that it's going to draw it backwards again. So it's completely forgotten what we were talking about previously. That's fine. I mean, this is what you need to expect. So I'm just going to copy these underneath there, and yeah, basically it is saying that well, it's got a little loop there. Let's change that loop so that it can take advantage of the new method. All right, let's see what happens. Draw spaceship was not declared. So what did I do wrong here? Did it? I'll just take the. No, what was it? Draw spaceship and erase spaceship. Why is it not seeing that? It's not seeing that because I've copied and pasted this code. I've left this code from the old loop in there. Yeah. I'm afraid it can't help you with that, Jerry. You do something stupid. So yeah, that's fine, except it forgot the backwards thing. And so we will need to change the code for that. We'll just ask it. And well, you change the functions to flip we're calling it a sprite, aren't we? To the right. Now this is code I could be writing myself. It comes to the point where, you know, what you're asking it to do takes more time, and correcting the mistakes takes more time than actually writing the code yourself. And that's really the line that you need to draw in the sand, as it were, with using artificial intelligence to do this sort of code for you. Is, you know, where did you start thinking for yourself? But in this tutorial, in this example, I'm trying to give you an understanding of how you can use this AI. So we're going to persevere with as much of it as we can. The problem that we have at the moment is that this display is actually made up of 4 different LED modules, each 8 by 8 pixels in size, and the routine that is drawing on it at the moment is basically only referencing the first module, module 0. So that's module 0 here, module 1, 2, 3. And you can see in the code where it's going set LED, it's going set LED 0. So that means that it's going to the first module and it's using the 8 pixels there. At the moment, it doesn't understand, or the code doesn't understand, that we're actually have one gigantic module, which is actually 8 rows and 32 columns. And in order to address each individual one, that you need to understand where which module it is that you want to turn it on, and then which pixel in that module that you want. And that's not very convenient for us. What we'd like to do is to say, well, X and Y0 is top left, and it goes to bottom right would be X32 or X31 and row 7 and Y7. So we need to write a routine that lets us plot pixels on and off based on that X and Y coordinates, rather than the way that it works with the modules. So it might be a bit of an ask, but we'll go back to chat and see if we can't ask it to, or explain what's going on and ask it if it can write us some code. So we can say the display is made up of 4 modules to give us 32 columns and 8 rows. Can you use the setLed function, but allow us to see to use X and Y over the entire 4 modules. I don't think I could even understand that. If somebody explained that to me, I have no idea what it's going to do. But here we go. Yes, you can modify the setLed to allow to use X and Y coordinates over the entire 32 by 8 matrix instead of just a single module. Wow, that's just mind-blowingly good understanding of what it is that I'm asking. In this modified function, we first determine which module led. Yes, it is by dividing it by 8. Yes. So that sounds quite reasonable. Well, let's have a look. So it's determining which module it is. Does the position of X determine the real position and then turn it on? Wow, that's amazing if that actually works straight off the bat. I mean, it truly does seem to understand what it is that I'm asking. Whether it gets the code right, I don't know, but it's doing a great job of attempting that. So it's created this setLed function, good, which we can give it an X and Y. And what I will do is I'll add some code to also just set a LED going at the position that I want, just to test it. So let's set the LED at 0, 0, true. Basically set it on, and then so this will be in time with the spaceship, and then we'll set it off. So we'll turn it on and we'll turn it off at X0 and Y0. Let's see what happens. Okay, and I think it's turned that LED on there. Okay, so let's now try at X31, which should be the limit of the display. So I'm expecting this LED over here to light up. No, what did I do wrong? Oh, I changed the draw spaceship. Set load at 31. Sorry about that, Mr. Spaceship. No, and I can't see it turning on the LED at X31. So what is it? So is it going in the wrong direction again? Okay, I think I see what the problem is. When we actually initialize the LED controller, this value here tells it how many modules of LEDs that we have. And we've set it to 1, and there's actually 4. So let's see if that makes any difference. Yes. Okay. Let's just check the boundaries. So if it's working 100%, then if we put in X31 and Y7 and X31 and Y7 here, it should light up the pixel at the bottom left of the screen. Let's try that. Yeah, it does. Fantastic. Next, I want to change the XY coordinate system so the X0 is actually the top left rather than X31. I just thought it makes more sense in my mind because the spaceship is going to be on this side of the screen facing this way. And in my own head, I'd prefer if the calculation was done that way. I've already tried to ask Chat to flip the X coordinates and it doesn't quite get it. And, you know, that's part of the problem with using AI to do the code for you. You know, sooner or later you have to think about it yourself. And also you have to ask yourself, you know, is it worth going through the drama of keep asking it and refining a question when it's something very simple? So all I'm going to do is in the set LED routine is I'll just say, look, the X equals 31 minus X. So I'm simply saying that what was 31 is now 0. And that's really all that's required, I think. So we'll just stop that and restart it. And yeah, so we've got this LED lighting up here because it's still set to 31. So let's set that to 0 and that to 0. And we'll set Y to 0 as well. So what we're saying is hopefully there'll be top left pixel. Yeah, perfect. So I wouldn't be doing due diligence if I didn't write a routine that lit up all of the pixels on the screen just to make sure that all the calculations are 100%. And that sounds like something that that Chat could do for me. And let's try this. So we'll take the definition of the method we're calling. Given the following code, can you write a test function to light up all the pixels with a, say, 100 millisecond delay? colon, paste it, and see what happens. Okay, so no, it needs 32x and 8y. It's a bit cryptic, but see if it understands that. Yeah, it looks better. So for each y, and for each x, 32 of that. Sounds more than reasonable. Let's just copy and paste that into there. So it's just called test. I'll get rid of that. I will clean up all of this code later. But I really need to go through this methodology, or else it'll come back and cause a problem later on when I'm trying to move sprites around. There we go. So it's lighting up. So it's looping through each y value. So each row, 8 rows and 32 columns, and just lighting them all up. Nice. Okay, that's enough for part 1. I've cleaned up this code a little bit. I've added a comment at the top. You can find this particular code by going to the WalkWe website and searching for Jerry's Tech Arcade Game -1.1. Obviously, the link will be in the description as well. I have renamed the buttons so that they do, indicate what they're doing. So there's a button for fire, moving forward, up, left, down. I've also modified the set LED function that we created to set pixel. So this is the one that will take an X and Y coordinates. I've modified the draw spaceship routine, so it will draw the spaceship using the set pixel routine, and we're also logging the information about the button. So if we run the program and you press button up, it's logging that fact, button left, down, fire, etc. So the next stage will obviously be hooking up the buttons into the logic so it can control the movement of the spaceship, and adding some aliens and some firing and explosions and perhaps, all the good stuff. So I'll see you there. Ciao.